Ok, pendant que les gens s'installent ou partent, mon nom est Jean Pons, je suis directeur scientifique de l'Institut 3I à Prairie à Paris. Et c'est moi qui vais chairer cette session. Je pense que la plupart du public est francophone. Si quelqu'un a des problèmes avec le français, exprimez-vous en anglais. Ou s'il y a des gens pas francophones, dites-le nous et que les gens s'expriment en anglais. Donc il y a 3 minutes par pitch. Is there anyone who doesn't speak French? Don't be shy. Okay, so maybe for these people who have the energy, do it in English so everybody understands. It's all in English? Then, okay, so I apologize for that. So it will be 3 minutes per person, then will be a bunch of questions at the end. So please keep sharp on the time, and they will yell at you and wave at you and stuff if you are late. So without further ado, let's start. And right. So I call Ryan Chiki from Monsieur Pasteur.
Okay, so 3 minutes. Please stop me at 3 because I don't have a timer. Excellent, thanks. Oh, I'm already consuming my time, huh? So, wow, that's super hard. It's fine. I can get started. So, good afternoon, everybody. I'm a not so young researcher because I just passed my HDR last year, and yeah, thanks. And I lead a lab at Institut Pasteur. This is a small team you can see on the right in bioinformatics. So we are one of the only computer science shops in a microbiology institute. You might be wondering what we do. And we do genomics using algorithms, and we analyze big data. And thanks to Prairie, we are getting started to, Prairie is a Parisian AI consortium. We are getting started to use AI in our projects. I will talk a bit later about that. And the mascot of our team is my pet axolotl here. And we actually study that organism in genomics quite a lot. Can you go to the next slide, please? Plus fort? Okay. Like this? Okay. I will briefly talk about a few projects. Our highlight is this one on viruses. We recently did a very big data analysis. And if you might know that if you want to do AI, it's important to have good data. And what we did is use cloud analysis to analyze petabytes of genome data. And we discovered a lot of new viruses. You might be wondering, is it good news? Is it bad news to discover all these viruses? And in fact, you may want to be warned of the next pandemic before it comes to us, which was pretty bad news 2 years ago. And in fact, we discovered a new coronavirus family, but it only infects aquatic animals so far. So we should be fine. And to give some examples, we also use algorithms and in fact AI in studying metagenomes and ancient DNA. And for ancient DNA, we use machine learning to decontaminate samples from ancient bones to remove everything from the soil and new bacteria and stuff like that. And that's my pitch. How much minutes do we have left? Oh, that was way faster. Any questions? Yeah. Oh, yeah, so researchers who study ancient DNA are faced with a big problem. So they have samples coming from soil that was buried in a long time ago. Ancient DNA is bad quality. It's also contaminated by everything else from the soil, from the skin of the remnants. And so their data is bad. And they only are interested in ancient microbes or ancient viruses from the host. And decontaminating is very difficult. So they use computational tools, such as the one we developed. Thanks for the question.
Thank you. I think in general, the questions we should leave for the end because there's really no time. So next is Pierre Colombo from Supélec, who's going to talk about anonymization, I think.
So, hi everyone. My name is Pierre Colombo, so I'm a postdoctoral researcher at CNRS, and more specifically, I'm attached to L2S, which is a joint lab with Centrale Supélec. So my main research focuses on tools and methods for reliable AI, and during my PhD, I mainly focused on language and its application, because I think it's fundamental in many businesses and society. Also, I started in NLP. I also start to work in image, and our work have been published in many AI conferences, such as NeurIPS, ATL, EMNLP, and 2 weeks ago, we received the best paper at AAAI. So I have the chance to work with people from around the world. So, for instance, Canada, US, South America, and also in Europe. So, next slide, please. So, and just to give you a more broader view of what I do research-wise. So, this is the classical ML pipeline. So, you have three stages. So, data collection, then you have the ML model, and then you have some analysis tool. And when business and like in research, we mainly focuses on data collection and ML models. So, they are quite efficient now. I mean, they can solve a large variety of tasks, but we often forget all these analysis tools. And I'm trying to focus on this one, and I have 3 main research directions. So fairness, how to make predictions that do not harm a minority group. Robustness, so how to make robust prediction, for instance, in presence of OOD data, out of distribution data, or adversarial attacks, and I'm also focusing on evaluation, so how to evaluate ML systems. So if I have one message today, it's like just stop focusing on the models. So there is also a part in the ML pipeline that need to be investigated. And we also started a startup whose name is Altica, and that focus on the analysis tool. So thank you, and if you have any questions, you can take them.
Thank you very much. Next is Rudy Morel from École Normale Supérieure.
Hi everyone. So I'm Rudy Morel. I'm from the ENS. I'm a PhD in data science, AI, and math, and I'm also a member of the digital humanities at the École Normale. I'm interested in time series. What is time series? Very simply, it's just data you have indexed by time. Here you can see, the screen is a little small, but you can see the recording of an earthquake from 3 different stations. And people have been studying a lot the time structure, how these processes work a long time. In the past decade, there has been a lot of developments. But what about going to the multiple series in order to better understand your phenomena? And here, this is an illustrative case where if you have several recordings, you can see different time arrivals that will typically enable you to locate the epicenter of the earthquake. So it's just an illustration of the general goal, which is to take advantage of the multiple series to better understand your phenomena. So that's what I do. For that, you have neural networks that are easy to use, that are called scattering networks, introduced by Stéphane Malin. It's not a research presentation, so I'm not going to talk about that. If we can go to the next slide, thank you. There is a very interesting case, which is what happens when the underlying phenomena is the activity of the brain. The activity of the brain can be measured at different brain areas, and so you get multiple time series of the same phenomena. What are we going to explain? We're going to detect phenomena that happen simultaneously on 2 electrodes and not on the others. When you detect it, it typically means that you have some brain areas that are connected and some others that are not. So that's the idea of taking advantage of the multiple series to better understand the phenomena. And so, in the end, just to conclude, why am I here? Because in the long term, we want to use this to solve concrete problems. So we're happy to talk with investors, professionals. And just to conclude very quickly, I like to think to this sentence that, scientists tend to overestimate themselves as individuals, but underestimate themselves collectively. So that's typically why I'm here. Thank you.
Thank you much. So next, I'm sorry, I'm going to mispronounce your name, but Eunice, or I don't know if you say Eunice Akani.
Good morning, my name is Eunice Akani. I'm a PhD student at Enedis, attached to the LIST laboratory of Aix-Marseille University. So to start, I will make a small presentation of Enedis. Enedis is the main French distribution system operator, and there are a lot of raw data. And the biggest challenge is really to analyze and to exploit this data. And to do that, there are a laboratory that was created in 2018 at the City of the Innovation and Knowledge of Aix-Marseille University to process these data and help the agent focus on the tasks that have high value for the company. Sorry. So my PhD student and my PhD project is about text generation in deep learning for abstractive summarization. So to do that, imagine you have a lot of documents and you want to summarize it in one source document. So you have a document like a document in textual documents, you have a table document, and you are also a conversation. So you want to summarize all of them in one document. So to do so, you have to first analyze all the documents. You have to make a framework that will captures all the important information of all the documents, and finally make the summarization task. So in my laboratory at Enedis, we work on different thematics, and one project is HAPPY, a project that allows automatic distribution of tasks to an agent. So to do so, we integrate in this project many natural language processing systems. The first one is a name entity recognition system specific to Enedis, because there are a lot of information that are specific to Enedis. We want to extract on this data. The second system that was in this project is a proposal for automatic response. And all their system is based on the Enedis language models. That means that the model can understand how the Enedis agents talk and speak and write. So that's it. So why I'm here today? Because my future ambition is to create an AI school, to open an AI school, and also to have a consulting thing. So to do that, I need some partnership with university or startup, and also researcher. That's it. Thank you.
Thank you very much. Next is Samuel Renaud from Luxembourg Institute of Science and Technology.
Hello, thank you. So I'm Samuel Renaud, indeed, from the Luxembourg Institute of Science and Technology. Luxembourg Institute list in short is Luxembourg RTO. So we are a research and technology organization that bridge the gap between applied science and academics. So we work together with academic and with industrial partners. So we are 4 departments, but I belong to the informatics department. In the informatics department, we are more or less 100 people. Half of them are dealing with AI in general. So not all are researchers in AI, but are using AI for their own research. But we have a specific unit and a very specific group that are very focused on AI, and in particular on AI trustability. And I recently have been appointed to one technology and innovation line that deals with explainability of AI system and regulatory sandbox. We also have a small but useful infrastructure, hybrid, both on cloud and on-premise, with several clusters, several stacks of AI technology, and a nice visualization wall, which is 7 by 2 meters. I think it's 51 million pixels, so it's very useful when you have to analyze a large data set. So next slide. To explain the partnership we are looking for, here is our project portfolio. So we are used to work with a competitive project in Europe, but also at national level. But we are also close to private partner and industrial, and we perform collaborative project together with Zeus Industrial. And one example is an industrial partner active in the field of powder metallurgy, ceratizit. And here with them we have developed an AI model to predict the outcome of a physical effect that occurs in production based on past production parameters. This allows them to reduce the scrap and to gain time in the downwards production steps. But we have other collaboration with other industrial, and in general we are open to any form of collaboration with academic and with industrial, where trust and explainability and of course data sovereignty is the key. Thanks.
Thank you very much. Next is Federica Granese. Again, sorry for... No? Pas sur ma liste. C'était qui?
Oui, mais c'est entre les deux. Mais il y a son nom qui s'affiche.
Ah, pardon. Geraldo Granados or Geraldo? Sorry. You're not the put you on the list.
Okay. Hi everyone. Thank you for having me here. So I'm happy to present you my research project. At the just to start, I would like to thank to the embassy and also to all the partnerships involved in the project. This project is financial by the European 2020 program, so it's an example of what we heard before. It's nice to see some faces behind these programs, and it's based in the CIA, exactly. So the title of the thesis project is a machine learning-based simulations of realistic signal for enhanced automatic diagnostics. So I will try to describe a little bit this. We start from a forward problem model. We try to develop a surrogated model that intends to make up all the simulated data. So we have what we call low fidelity data that we can produce faster, that come from simulators provided by CUA. And we developed this surrogated model to make up or to improve the data to seems like experimental data. So in this, during the training on this model, I have two data sets, a big one coming from simulation, and a small one coming from experience that is really costly to produce. The aims of this multi-fidelity simulation is to then utilize this high fidelity hybrid data that seems like the high fidelity data that we use when we're training, to improve the diagnostic tools in NDT problems, like non-destructive tests in materials. So problems like regression, classification, statistical analysis that are already done in the lab, but only based on the simulation data. So we want to improve those tools that later are deployed in the industry, but really they are deployed in real data that are performed by operators. So we need to learn all the environmental noise introduced and all the different accuracy that we have once we look to real data in real world. So we can go to the next slide. This project is done with the help of two laboratories, one in the Central Supélec laboratory, and that is mechanical laboratory of Paris-Saclay. that provides the high quality and high fidelity model to produce all the main of the simulated data. And on the other hand, we have CList that provide the simulated fast data. Here you can see the domains of each laboratory. So if you are interested in one of the domain, or mainly in the topic I'm talking about, non-destructive test in materials and metallic parts, I will be interested to work with you. So I think that we're in the time. Thank you.
I put on the mask because I think this is a recipe for COVID, to have 15 people speaking in a mic. So I apologize for those that didn't do it before. But I encourage the speakers, if they have a mask, to put it on. And I apologize, sorry, I just don't want you to be sick or anything. So this time we are going to have Federica Granese again. And again, sorry for this, it's just for you.
Yes. So, hello everyone, I am Federica, and I am a third year PhD candidate at Institut Polytechnique de Paris, together with Sapienza University of Rome. And I am a member of the committee team in Iria Saclay. So basically, my work lies in the field of safety and security in AI. And in particularly on the safety side, we have developed Doctor, a simple method for detecting misclassification error. So basically here the idea is that given a pre-trained model, it is possible to understand whether a sample in input is going to be correctly classified by the classifier or not. And this only by looking at the softmax output given from the network. So it's a really simple tool because it does not require any training, and it basically relies on the approximation of the true error probability of the classifier, basically. And this project, or rather this paper, has been accepted to NeoRIPS 2021 as a spotlight this year. Then on the other side, more on the security side, we can say, we have other two projects. The first one is about detection of adversarial examples. And in this case, what we are trying to do is to develop a new framework with which we can evaluate the detected methods in a more general way that is basically more realistic than it is done until now, basically in literature. And then we have another project, this one is just started, that is about differential privacy. And here, what we are trying to understand is to what an extent a final user can basically infer information about the level of protection of his data. So we can say that, okay, this project here, it's not actually really related to machine learning, but of course can be extended. And as a further step, what we are trying to do in the case of the safety project, so the one of Doctor, more like to develop this method even for other cases. So for example, for regression, because what we have until now can work for classification, but not for regression. And in any case, we are also going ahead with these other two projects, trying to develop more for also looking at more realistic setting. So that's all.
Thank you very much. Thank you very much. Next is Marine Picot from Central Supélec.
Hi everyone, I'm a PhD student in L2S, Laboratoire des Systèmes in Central Supélec, and in a co-title with McGill University in Montreal, Canada. And my work is also focused on improving the security of neural network. So actually, it's fairly easy to attack a deep neural network. One of the ways to attack it is through what we call adversarial examples. So it's very small additive noise that we're going to add to the inputs in order to fool the classifier. So a very common example is this one. So we have a photo of a panda, and the model is actually classifying it as a panda with a confidence of around 50%. And when we add this patch with an amplitude that is very small compared to the first amplitude, we have now an image that is still a panda, but the model thinks it's a given, so a small monkey. And this time it's very confident in its mistake. it's extremely important to actually have security in neural networks, for two main fields, and most critical applications. So the first one is security, and the second one is safety, because it has been proven that it was possible to actually transfer the adversarial example to the real world. Can we? How to defend against those adversarial examples? There's two main ways. The first one is what we call robustness. So we are going to try to train a new classifier that is going to rightfully classify the example, even in the presence of the perturbation. And the second way is through detection. So we are going to use statistical analysis on the image and on the model in order to extract features that are going to allow us to determine if it's clean or attacked. In both cases, we developed tools based on statistics in order to improve the state of the art. Thank you.
Thank you. Next, sorry again from Xijing Zhang, more or less, from ENS Paris-Saclay.
Yes, 50 years ago, I was studying Jean-Paul's class on computer vision. So I'm very glad to present my research activities at NET in Toulouse and also scientific collaborations that we'd like to develop. NET is a Toulouse institute dedicated to AI for research and education. There are two key application sectors, which are transport and robotics, with more than 50 partners. There are more than 200 researchers and 3 integrated programs and 24 scientific chairs, with three research axes that are acceptable AI, certifiable AI, and collaborative AI. My research activities fall into the first 2 axes with 2 directions. One is to understand machine learning models for classification and regression problems with complex data. The idea is to build models of data so as to characterize intrinsic structures of data that are learned in deep learning models. Another direction is to apply machine learning to data assimilation. Data assimilation is an inverse problem like image denoising in signal processing. And the idea here is to combine physical models developed in data assimilation with deep learning models so as to improve the state of the art. In all these directions, we also study optimization and game algorithms in order to solve a problem. Next page. And there are we'd like to develop scientific collaboration with both industry and academy. After COVID, Toulouse wants to move beyond the transport and the robotics. In particular, we'd like to work with people in health and environment. Also, we'd like to study deep learning or image or time series analysis and modeling. So one topic would be to study generative models of images and time series. So you can see there are many, they cover a broad range of domains. And the question we want to study is fundamental research in the understanding of the randomness of data. And another topic would be to study data assimilation with recurrent neural networks. The idea is to predict or understand a dynamical system at a future time. And here we can see if we, for a dynamical system which is periodic or chaotic or recurrent, there are underlying knowledge, domain knowledge. So we'd like to work with people who has a good domain knowledge so that we can build machine learning models to impose natural constraints to that important constraint to a model, so as to make the model that's safe to the society. So that's the ambition. Thank you very much for your attention.
Thank you, thank you. Next is Marie Garin from ENS Paris-Saclay. That's okay.
So good afternoon to all of you, and thank you for your attendance. So my name is Marie, I am a PhD student at the Interdisciplinary Research Center, Centre Borelli, at INS Paris-Saclay. It's a main hosting institution. So this laboratory is a mixed research unit, bringing together researchers in mathematics, computer science, and neuroscience, and all those researchers are involved in interfaces with biomedical fields and with industrial transfer. We notably work with a network of several hospitals. My research is oriented around two axes. So the first one is privacy-preserving machine learning. So traditionally in machine learning, data is gathered at a single location. So this widespread architecture faces a lot of constraints. So the crucial one being privacy and latency. So that's why the machine learning community has a search alternative to centralized learning. So one of them is federated learning. So it's a new field of growing emphasis. And so in this field, the main point is that the data are stored locally, and you train the model locally too. So there is two main advantage for this for keeping data locally. So the first one is that it preserves privacy, unapodictic values whose endangerment can entail insidious societal effects such as self-censorship. And the second one is that it enables to collaboratively learn even if data sharing is impracticable or even illegal. And my second axe of research can be reflected by the organization of this seminar. So the Séminaire critique de l'intelligence artificielle, CIA for the little joke. So this seminar is inspired by critical theory as developed by the sociologist Horkheimer and the philosopher Adorno. And this seminar wishes to instill an epistemological reflection about AI at a time when AI seems to be totalizing. So and raising the following questions. So what are the limits of AI? Who and how is produced the knowledge? So notably the data. What in the collective imagination belongs to myth or ideology? What are the power relationships between all the actors? So between research, industry, governments, and what is its social relevance at a time of the ecological stress? And so if you want to attend this seminar, you can do it on Zoom. So yes, okay. Thanks.
Thank you. Next is Louis Escouflair from the University Catholique de Louvain.
So, hello everyone. My name is Louis Escouflair, and I'm a PhD researcher in computational linguistics at UC Louvain, more specifically at the Media Research Observatory and Center for NLP at UC Louvain. I'm here to present, to pitch my project, which is called OpiNews, and its main goal is to build an algorithm that would be capable of automatically detecting, measuring and analyzing subjectivity, linguistic subjectivity in French press articles. So why did we want to start this project? Because we noticed that in a lot of people in Europe, actually around 40% of the European population gets their information, their daily news directly from social media, from Facebook, Instagram, Twitter, TikTok. A lot of people get their news articles from there. But the problem is that, of course, these news articles are pushed by recommendation algorithms, and that the articles that we see most are also the ones that will provoke the most emotions to the readers, because that's the one that they want to push forward. And of course, these articles are also the ones that are the most polarizing, the most polarized, and that contain the most subjectivity. We do not want to eradicate opinion from journalism because there will always be a place for opinion. What we want to do is to help the readers understand when what they're reading is pure fact or when it's tainted, influenced by the opinion or the point of view of the journalist that wrote the article. There are many applications that are possible with this algorithm. We could help journalists write or correct their articles to make them less subjective. We could also imagine a website that would allow the people to pick an information and see what every media has said about it. If some media are biased towards one position, if other media are biased towards another position, and so help the people to make their own opinion about a news and not just follow one single media's opinion. So, of course, we need data to build such an algorithm. For now, we are working with data from the French Belgian public service media, so RTBF. We already have good results, but it's hard to extend our results to other media or to articles coming from other types of media. And so that's why we're looking if anyone here happens to have access or to have contacts that could help us get data from other French press groups or Belgian French groups or even from other countries. We're also open to French data or Quebecois data. So yeah, thank you for your attention.
Thank you. The next is Carmen Mazzen. Sorry.
Don't worry. Good afternoon, everyone. My name is Carmen Mazzen. I'm a PhD researcher at VUB, so just around the corner. And I work in an interdisciplinary research group, which is also part of the data analytics laboratory. And we aim to develop human-centered AI. The evolution of AI has been incredible in the past decades. Dimension, speed, vastness was impressive. Yeah, unfortunately, sometimes things go wrong. AI systems do not understand what we mean by human values, and therefore they can create or propagate biases. And that's something that we don't want. We like algorithmic fairness. The bad news first, fairness is a philosophical concept, and each one of us will have a different definition of what that means and how it can be implemented. Secondly, there's no silver bullet. There's no way that you can just flick a switch and everything is solved. And that is because bias creeps into your systems in all of the steps of your development phase. In the data collection, in the training of your model, but also in the application of your model. And in our group, we are looking at how to solve that. And I'd like to present two examples of what we've been doing in the past years. Maybe starting under here. So fairness definitions, there's a lot of them, and there's also trade-offs between them, which is unfortunate. And we developed a tool to visualize this trade-off, and that also helps by seeing in which regions or in which situations this trade-off is minimal. And we've also shown that it is possible, that in some situations it is minimal. And then secondly, on the top here, it also happens a lot that you have a model, but you don't have access to the training data because of whatever reasons. And then you still would like to evaluate if this model is fair or not. And how we do this is by a new technique where we fix the outputs and we ask the model what is the ideal input for that specific output. So which data activates you the most to give us this specific output. And in that way we can evaluate if the model has preferences for certain characteristics of protected features, which we would not like to. And yeah, the image here is a visualization where you could see this model, for example, had a preference for people who were married to a woman, which is not half of the population, let's say. Next slide, please. So why am I here? I am very interested in getting to know you, the other young researchers working on these topics. And then I'm also looking for data sets, because the tools that we've developed, we are using at the moment on publicly available data sets, but it would be interesting to see in what happens on real life data sets. So these are my contact details. I look forward to talk to you later.
All right. Next is Lisa Kutsoviti-Kumeri.
Yeah, very good.
Thank you.
Thank you.
From the University of Hasselt.
Indeed. Hello, everyone. You can hear me, right? So I am the fourth researcher who is working on fairness and explainable AI. I am doing a PhD at Hasselt University, and I am part of the Business Informatics Research Group. What my research tries to answer is, how do we make sure that features in our data are not biased? Why is this important? Nowadays, companies need to be accountable. They need to explain why they took certain decisions. To give an example, let's say that a bank needs to classify loan applicants in terms of being eligible or not to get this loan. And they use certain attributes for that, say the checking account, their employment. But they might also use some variables like gender. And I think we can all agree that decisions should, like classifying somebody in terms of creditworthiness, should not be based on the gender of somebody. How do we make sure of that? Can we go on? So there are many measures that have been developed for that. Carmen already mentioned some of them. So there are many fairness definitions. Some of them are based on statistics, correlation methods, linear regression, etc. We have created two novel measures that are based on two fundamentally different methods. The first measure uses fuzzy rough sets to measure explicit bias in data. It assigns a certain percentage to a feature in the data, which means this percentage represents the influence of that feature on the classification outcome. For example, if gender gets a very high percentage relative to the other features, then we can say that our data might be biased against gender. So we, of course, compared our measure to baseline approaches, and we found exactly the opposite results, which allowed us to conclude that maybe we are reflecting a new type of bias. The second bias measure measures implicit bias. And to do that, we use fuzzy cognitive maps. Again, this measure assigns, again, a percentage to each feature in the data. And this percentage reflects the influence of all other features on a certain, let's say, biased feature. Fuzzy cognitive maps allow us to measure all interactions within a complex system. And in this way, we account for implicit bias. We have published both these measures on 2 journal papers, but we again used them on publicly available datasets. We would love to test them on real-life datasets, and I would also love to cooperate with researchers also in the field of fairness and maybe encourage them to use our measures and see how we can arrive to some interesting results. My email is here on the slides. I will be happy to share also my LinkedIn profile with you and stay in contact. Thank you.
I think we have our last speaker, Mylène Maignan from École Normale.
So hi to you all. My name is Mylène Maignan. I'm a third-year PhD student at the École Normale Supérieure Rue d'Ulm, where I study data science and literature at the same time. Having obtained 2 master's degrees, one in literature, both from Sorbonne University and the other one from King's College London, and another master's degree in digital humanities or in computer science from École Nationale des Chartes in Paris. I then obtained a scholarship to conduct my research in data science and English literature. I'm part of the Lattice Lab, which is a multidisciplinary unit within the École Normale Supérieure, and it gathers a lot of different academics coming from various backgrounds, such as in natural language processing, cognitive linguistics, or digital humanities. My PhD consists in exploring a literary corpus thanks to digital tools. I created a data set of more than 40,000 theatre reviews, all of them related to the London contemporary drama stage. And very concretely, what I do is I use computational techniques to study English literature. So I might use natural language processing, machine learning, sentiment analysis, digital maps, in order to better understand literary history and theories thanks to numbers and to statistics. I created a website which is called dramacritics.com. So if you're curious and interested in my work, you can visit it. So can I have the second? Yeah, thanks. So my research is almost done, and my PhD defense is due in a couple of months. So I would be eager to find a position as either a product owner or a digital project manager, supervising the creation of databases, managing the backlog, or analyzing and visualizing data, or even actually collaborating with UI or UX designers are very interesting tasks that I would be happy to help with. And my background in computer science enabled me to have an excellent command of Python, R, and HTML languages, and also, of course, machine learning techniques. And bilingual in English and in French, my studies in literature also helps me develop a sharp knowledge of both languages, which are valuable assets in communication and marketing fields. So if you're looking for someone, there I am. And thank you for your attention.